Hello there. Today I would like to talk about implementing red-black trees. Hello there. Today I would like to talk about implementing red-black trees, and more specifically, how to perform a right rotation. Now, with red-black trees, there are two types of rotation actually, where you can perform a left or a right rotation. And usually you'll do them if one of these red-black tree properties has been broken here. It's very important to keep these properties enforced. It's what makes a red-black tree a red-black tree. And it's what makes the red-black trees themselves faster and just better data structures in general than a regular tree. So when do you perform rotations? You normally perform rotations after you insert a new node into the tree. And I already have these methods implemented here for inserting. And if you find that there is one of these red-black tree properties broken, well, then you're going to go ahead and figure out the child and the parent that are associated with that broken property, and you're going to have to perform these rotations. And now you might have to dig into that a little more because sometimes these issues propagate up and down the tree, so you'll have to figure out exactly where it starts and how many rotations you need to do to end it. But I'm not going to get into that in this tutorial. I'm just going to talk about performing the right rotation itself. I had a student come to me who was a little confused on how to do it because they were getting lost in keeping track of all of these different references and nodes, and it can be a difficult task. So what I like to do when I'm approaching a new data structure or topic I'm unfamiliar with is I just like to be very explicit and just write everything out, draw diagrams, follow them, just to keep myself clear, and then I'll go from there to enhance it and make the code look prettier. But what you'll need for rotating is you'll first need a method where you check if the child is the left child or if the child was a right child. And usually when the child is the left child, you perform a right rotation, as seen in this picture here. I tried pointing at it, but you can't see my finger. And if the child was the right child of the parent, well, then you perform a left rotation. So like I said, I'm just going to be talking about this case here where we perform a rotate right. So let's get into this method, this helper method we have for implementing that. So I went through the liberty of getting each of the nodes in the diagram, and I put them in special variables to match the colors in these pictures. Be careful with the red and black because that might not always be the case because we are working with red-black trees, but just be careful using those keywords in this scenario. I only did it for the purposes of this diagram here, but you really might want to be careful using that because it might give people the wrong idea of what exactly is stored in those nodes because it might not always be a red or a black node, you know? I hope that makes sense. So anyways, as you can see here, let's say we have this little diagram on the left. So this would be the grandparent. So we got that using the parent's parent, which makes sense. We have P for parent here. And red would be the parent one. Black would be the child. Yellow would be the child's left child. Green would be the child's right child. Pink would be the parent's right child. And these are triangles because there can be whole subtrees underneath them. And these nodes might just be roots of those subtrees. So essentially, instead of just moving single nodes, we might be moving entire subtrees, or more specifically, references. And that is what you have to be careful of doing because you have to make sure that, if in this diagram here, this green one must be the values between 18 and 22. We see that. And now, when we rotate it, 18 becomes the new parent and 22 becomes a child. So we have to make sure that everything in the green subtree still stays in between 18 and 22. We can't have it over here because if we have a 24, or I'm sorry, if we have a 20, you can't have this one still on the right because 20 is not greater than 22. So that's enough explaining. Let's get into the code. So the first thing we're going to need to do, which is actually one of the most important steps, is we're going to have to check that if this node here, this orange one, even exists. Because if it doesn't exist, well, then we know that the parent is the root of the tree. And after rotating it, we're going to have to make sure that the root becomes this child that does not stay the red one. So let's first say if orange equals null. And again, if orange equals null, then we know that the parent must be the root of the tree, because the entire tree, because if some node in a tree doesn't have a parent, well, we know that that's the root because it's the only case where a node could not have a parent. So if orange is null, then we're going to have to say, okay, that root, so the root of the entire red-black tree, is going to now equal the black node, which is the child. But if orange isn't null, well, then we're going to have to say, okay, was the parent the left child or the right child of the orange node? Because once we put the black one into its place, we're going to have to make sure that we set it to the correct child. Because, like, let me add a little bit here. If I had these, let's say, we don't want this black one to become the right child of the orange one now. We want it to stay the left child, if that makes sense there. So, in my else, we're going to say if parent is left child, then we want the orange left child to equal black. Else, so if the parent is the right child, then we want the orange right child to become the red. Or, my bad, the black as well. And after doing that, all we'll need to do now is work with these nodes here and make sure that these subtrees stay within their correct bounds. And that's essentially just going to be reassigning references, and should be the easiest stuff to get through in this tutorial. This would probably be the hardest part of it. So if you got through that, well done. So all we need to do now is just update references. So let's say the parent, or the black node now, its parent should be the orange node, right? Because it's now just become in this position here. So its new parent should be the orange one. It should no longer be the red one. And so now, the black right child should equal the red node. The black left child should equal the yellow. And the parent left child should now equal green. And the parent right child should now equal pink. There we go. And I believe you should also be updating one more thing. I could be wrong. I think I'm missing something. Parent, should the child become the parent's parent? I think so. Oh yeah. This is red. Just to make sure we keep that clear. So the red parent will then also become the child now. Because if it was this orange one, well, we want it to be the black one now, to keep things clear with our diagram. Just remember that black was the child, red was the parent. So that should be good for your right rotation. I hope this helps. The left rotation is as simple It's as simple as turning, if I can do this, turning this arrow around. Okay. OneNote does not really like to work with people ever. I do not recommend it if you're looking for a note-taking app. It just is, it's not. It's as simple as doing it like this. You just switch the arrow and you do the same thing. But this would be the parent and child, and this would be the child and parent. Like, you just have to follow the diagram, but the other order. So I hope this helps. If you have any questions, feel free to leave comments. And yeah.